Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil Hakim bin Muhammad Suhaimi, and my supervisor is Puan Halia binti Harun. And today I would like to present my PSM project, which is the title is Development of the Prototype Automatic Portable Lifter for Carry Student Goods. Okay, I will start with introduction. Okay, the human already use the lifting system for many tasks. For example, hoisting the water, the building the pyramid, ramp, citadel, and castle. But nowadays, the upgrade of this system is involved rapidly in their own application. And for example, in manufacturing sector, and the problem is with the existing of this system in some university college, which is some college do not have a lifting system for the building 5 floor, which is with this problem, it creating the problem for the student. For example, if student from 5th floor, it need to take in their belonging one by one. Okay. Okay, the objective for this project is to design and development a model size of portable automatic lifting system to transport a student belonging. A second is to implement the device prototype into the public building without permanent attachment. And finally, to analyze and perform the performance and the practicality and reliability of this project. Okay, for the scope of the project, it be six. First is the design approach of prototype is portable and removable. Second is to demonstrate a lifting system could transport a vertical weight load 5 kg for one movement. And third is to structure the material will be based on mild steel. Fourth, the mate of the structure will be mounted by welding. Fifth, mechanism of pulling the kite must be by using motor. And six, create a model size do not exceed 1 meter height and 700 centimeter width and 500 centimeter length. Okay, now about a literature review. For the research study, we already found about lifting system in manufacturing sector, which is in this topic is overview of lifting system in manufacturing sector, which is consists of forklift and cargo lifter. A forklift is a mechanical device used to lift or transport heavy material. It consists of hydraulic system that can rise and lower the platform or fork onto which the material are placed. The distribution of the weight and the center of gravity is important to design a forklift. And for the cargo lifter is a mechanical device that used to transport a good between the different level of the building or structure. Commonly used to warehouse, a factory, and auto device industry setting, and they can be used designed to handle the wide range of cargo size weight. Okay, moreover, from the overview of the lifting system, I already get some initial design, which is I be constructed by two, which is a type of movement system. The movement system that I be choose is pulley system, which is more suitable and more easy to maintain. And for the type of drive mechanism, I using the electric motor DC to contribute in pulley system. Okay, for this part, I divide to mechanical component and electrical component, which is in mechanical component, we already have a rise and lower component. For this component, I select a guide array, which is for the linear movement for the for my prototype, and the pulley because pulley system I will use. For the pulley system, why I using pulley system because the mechanical advantage of the pulley. Second is type of material structure component, which is steel. For the related electric component, for the controller, I use not MCU. For the type of sensor, I using proximity sensor. And last but not least, for addition, I using the motor driver. Okay, for the method of assembly, I will choose a permanent joint of welding. A permanent joint is welding, and non-permanent joint I will use a bolt and nut. Okay, for the summary for this literature review, I already conclude that for the initial design, I will choose design like a forklift or cargo lifter because these two design are having their load in front of the system. Okay, for the type of the movement system, I will choose the pulley system because it's more easy to maintain, more cheap for beside of the another type which is hydraulic and pneumatic. For the driver system, I choose the motor electric because I would my prototype is automatic and I already use motor DC direct current. For the rest and lower movement, because I choose a pulley system, I use a pulley, which is the pulley. If the more diameter of the pulley, the more the mechanical advantage that we get, and also for the guide rail, because I want to be the system or the prototype of a linear system, a linear movement. Okay, for the material, I choose my steel because it more cheaper than aluminum profile and more rigid, more strong, and it for more important can weld. For the controller, I use not MCU beside than Arduino because I would like to connect with the Wi-Fi, and the software I will use is um, Blink software, is IoT software. And for the sensor, I choose a proximity sensor because the proximity sensor is it can detect the movement object without contact. And for lastly, the motor driver because for initial idea, for initial material. Thank you. Okay. Uh, I would like to talk about a methodology. Okay. Here, which is a implementation of location, which is for this product or this prototype, we attach to the balcony of the public building or the building. Actually, if you saw in this three picture, which is the ground floor is where the platform or the prototype will be based. The side view of the balcony, which is having the circle shape or steel, which is be attached with the prototype, and this is a front view of balcony, which is where the prototype will be attached. Okay, for the mechanical design, this mechanical design of this prototype. If you can see, this prototype is height is 1,000, 1,000 millimeter with a width of 500 millimeter and having a length of 222 millimeter. And the second picture is figure is the part of the prototype that I will using, which is rectangle hollow mesh steel, U-shaped bracket, pulley system, T-track guide rail, square hollow mesh steel, and DC brush motor. Okay, for this section is about a prototype assembly section, which is because my prototype is plug and play. I want this prototype can be disassembled without having more joining. Okay, for the label A is showing U bracket that we use connect prototype to build the structure. Meanwhile, for the label B is showing the part that can be disassembled without, which consists card, motor, or base. The all disassembled part join with the bolt and nut. Meanwhile, the another part we join using MIG welding method. Okay, we will involve in about electrical design, which is for this session I will talk about the flowchart of the system. The flowchart is straightforward, which is the user need to select the desired flow using Blink software or the IoT software. After that, the microcontroller will process the input from the Blink software, and then the motor DC will move the card by data from the microcontroller and sensor. And last and not least, if the card is not moved, then we maybe have some error, which is and for the user need to select again the desired flow. I want to talk about the block diagram of the system, which is for this prototype, I using the solar panel or the solar to generate the power. Which is from the solar panel, it will send the energy to the solar charger control, which is will regulate the energy, and then from the energy it will restore into the battery, which is battery 12 volt and 9 volt. From the battery, if we first battery 9 volt will send the energy to the buck converter. Buck converter will convert the voltage of the battery to the different level and can the step down or to high or step up to if too low. The switch on is for off and off the manual switch to active the circuit. The NOT MCU ESP32 microcontroller is used to control the motor if the system to perform the task based on the input from the push button and the proximity sensor. The proximity sensor is detect the presence of the object, which the certain distance of the certain distance can be triggered the action of the system, such as the detecting of the movement of the card. And finally, a motor driver is control the operation of the motor. It can start or stop or control the speed and the direction of the control movement of the motor. Okay, for this section, I will like to talk about result and analysis. For this slide, I already showing the two of testing that I will perform, which is a function test. The function test is objective is to see the functionality of this prototype, and the testing be done by 10 cycle, which is during the 10 cycle, the observation of this prototype have been noted, which is to see the behavior of this prototype. Okay, for the result, we can see on this table, the cycle number 2, the car is not moving from fourth floor to third floor. And the cycle in number 7, the car not moving from second floor to third floor. Okay, from the observation from this problem, we detect that the sensor detect twice for the cycle number 7 and car not move downward to the car problem in cycle number 2. Okay, and next is for disassemble prototype, which is having a 7 joint disassemble part of this prototype. Okay, this part I will talk about lastly. Okay, for the sensor detect twice, we can see that when in the cycle number 7, which is when the user want to move the card from the second floor to third floor, the sensor detect twice because the cut of uh, the cut position is having a problem make the sensor detect twice. Okay, for the cycle number 2, the cut cannot move because of the position of the cut when it's downward. If what I observed that when having the downward movement, the cut need be tilted to the left to perform this movement or not. If cut in this horizontal, it will stuck it at the guide rail. Okay, this result can be showing from the figure at next slide. Okay, for the first figure, we can showing that this is the position for the cut for movement downward, and we can see it be tilted to the left. And the second figure is showing the cut when the position of the cut when it cannot move. This is because the guide rail, the cut will start with the guide rail. This is because if you can see the figure number 3, because of I was using just three joining bolt to join the cut and the cut structure. This is because due to when I join using 4 bolt, the cut cannot move at all. Okay, for the lastly, this is a figure about if you can see the circle, the red circle, which is the part that can disassemble, which is the 7 using the 7 joining and using a bolt and nut. Okay, this is a last test, which is a load test. For this testing, be done by identify the optimal weight of for the prototype. Each movement will be done by 5 times by changing the load is 9.18 Newton, 19.2 Newton, 29.43 Newton, 39.24 Newton, and 49.05 Newton, and taking the time taken data for the analysis. And this the table for the result of this testing, which you can see the data taken for movement upward and data taken for lift movement downward. Okay, this is a graph based on the result on the table before. Okay, if you can see, the time taken is increased by the load. This is because when the load is increased, the energy to perform it also increase. Okay, if you can see from the 9.18 Newton to 29.43, the temperature is still in 6, but after that is 7. And for the normal is already told the data is not consistent. This is because due to some of problem that will be encountered, and in this next slide we will be showing the problem that will be encountered. Okay, if you can see in the first figure, which is the card structure, we contact to the guide rail. Due of this, it having the friction. But in this system, supposedly they cannot having friction at all. We be free play. Due to this, the data that we get is not correctly or not precisely. Okay, the second video figure is about when the cycle be testing for output for 5 kg. When the be performed, the base need to be support with using leg or not. The base will tilt up. For this, we conclude that for this prototype, it can be lift or the lift for the load below for 5 kg. Okay, this for the conclusion. The prototype portable automatic lifter perform well in the ability to move below between 1 kg to the 5 kg from the one point to another point. However, there are some issues that can be improved upon the future. Despite of this issue, the purpose of the system functions smoothly and the connection between electrical component or be successful according to design plan. Using IoT, Blink IoT as a push button make it easy to run reduce the load for the wiring system. More of the issue were the observed with a mechanical problem which may affect the accuracy and precisely of the data collect. However, the main structure was in a good condition and did not show any crack or defect after this testing. For recommendation to begin with, the most significant improvement is need to lift this mechanism. The card attachment requires a significant improvement. One way of the improvement is using a suitable guide rail that will assist the smooth movement of the card. For instance, the guide rail can significantly less friction compared to the guide rail being used. Additionally, when the fabrication process is being carried out, the caution to create its detailed plan to avoid a potential mechanical issue. Okay, for the next video, I will show about the test. The Okay, for the next video, I will show the video demo about this prototype perform. Okay.
Okay, ni kita punya interface Blink, apps Blink. Kita akan, dia sekarang dekat ground floor, kita akan naik ke second floor. Okay, second floor, third floor. Fourth floor. Okay, sekarang ke third floor. Second floor. Dan last kali ground floor. Okay.